The topic we chose to address was domain and range. The domain is the set of all possible x values, while the range is the set of all possible y values. There is also the range of data, which is the lowest figure to the highest figure in a set of data.
Some of the common strengths found in both students of mathematical methods and further mathematics across Victoria were finding the domain of a linear graph when given the range, finding the range of a linear graph when given the domain, and finding the range of a graph when given a domain and a codomain of R.
Throughout the methods exams of the last 5 years, we found many weaknesses in the areas of domain and range, but we found 4 very common ones. Students often give answers that are either outside the restricted domain, or they give answers that don't include the domain constraints at all. Students tend to be pretty strong in the area of composite and inverse functions, but not with finding the domains and ranges of these functions. Students can often use notation very poorly, and a key example of this is knowing the difference between open and closed brackets and showing this through their answers. Here is a question from exam 1 of the 2017 methods exam. As we can see at the top of this question, it has been set out immediately that the domain is between -3 and 0, closed brackets. Now, part A isn't related to finding the domain or range of this function, but part B involves students having to draw the graph on a set of axes. Part B of this question was worth 3 marks, and only 36% of students acquired full marks for this part of it. The examiner's report cited a common mistake in this question, and that was that many students used R as the domain, instead of using the restricted domain that was given to them at the start of the question. This ties in with the first 2 common weaknesses in methods, that students often give answers that are outside the restricted domain, or they do not include domain constraints at all. Here we have another question from a methods exam of the past, and this is from the 2015 exam 1. We obviously see at the start of this question that students are being given a composite function to work with a set out domain from 0 to infinity, open brackets. Now in part 1 of question A, they have to find the rule for this function, while part B, they have to find the domain and range of it. Upon analysis, 55% of students did not acquire a single mark for this question. And this ties in with the other 2 common weaknesses that we found, in that students can often use poor notation, which can cause mistakes, and they struggle with the domains and ranges of inverse and composite functions. And the examiner's report even left a tip at the bottom for students to avoid making these mistakes in the future.
This question deals with a question that comes from the 2015 Further Mathematics Examination 2. The question provides data from 1975 to 2010, as the arrow indicates. However, in part 1 of the question, it asks students to predict what will happen in 2030. In part 2, it asks why the prediction made by the students when answering the question is only of limited reliability. In regards to part 2 of question B, 55% of students failed to get the 1 mark. This was due to the fact that students didn't realise that they were extrapolating when making the prediction in part 1 of the question. Instead, many students, as the quote from the Further Mathematics Examination 2 Examiner's Report says, it indicates that there was speculation from students and that they were guessing, and they actually lacked understanding of the data range and did not understand that they were extrapolating.
Students were often tested on their knowledge of domains and ranges from 2013 to 2015, but it's only in the last 2 years, with the change of study design, that examiners have begun to realise how common mistakes are in this area of mathematics, and they have started testing students' knowledge of this more on exams. This has led to more mistakes in the areas of domain and range, and more exposure to the problem that many students face in learning this properly in their mathematics classes.
In regards to the Year 7 to 10 curriculum in Victoria, the The topic of range is touched on throughout, although it's not explicitly linked to functions. And in regards to domain, it is rarely mentioned and only becomes more prominent in the curriculum in years 11 and 12. In terms of the curriculum for Year 11 General Mathematics units of 1 and 2 and Further Mathematics VC units 3 and 4, range is used to measure spread and also give students an understanding of the spread of a set of data. Students are expected to understand and be able to identify the key features of range and domain, and also realize when a domain is impracticable, such as in real life situations, understanding that many things will not go below 0. It should be noted though that the first mention of domain and range in relation to technology is not made until Further Mathematics, which is often students' last year of schooling. In terms of the curriculum for Mathematics Methods, CAS, Units 1 and 2 and 3 and 4, the domain is extremely prominent and relevant when dealing with circular functions, which is a big topic in methods. Also, codomains are brought up, which are not brought up in Further, as well as the relationship between the original functions domain and range, and the inverse of the functions domain and range. Domains and range play a big part in mathematical methods, as you can see on the points on the slide.
For our literature research, we looked at a number of different books and journal articles related to student understanding of domain and range. The first one we looked at, a geometric part to the concept of function, discussed how mapping functions to domain ranges using geometric representations can assist in development of understanding, and that students need to have an understanding that translations too are considered functions that map an input point to an output point. The second one we looked at, high school students' understanding of geometric transformations, discuss how students need a strong conceptual understanding of domain being a compilation of all points on a plane, and this includes graphical representations of datasets and would help reduce commonly made errors, such as those made in last year's Further Mathematics exam, wherein students were not including outliers on a box and whisker plot as part of the range. The book we looked at, Making the Connection, Research and Teaching in Undergraduate Mathematics, discuss how students who interpret graphs piecewise are less likely to correctly find the domain and range of a graph, as opposed to students who review the graph as a function rather than a set of coordinates. The fourth piece that we looked at, Visualizing the Domain and Range of the Composition of Functions, discuss how the use of new techniques in a classroom can assist in a student's development of understanding. In particular, graphical representations can be useful for determining the range and domain of functions, especially for students who are more visual learners. The use of rote learning in a classroom is found to stagnate a student's development and stun their understanding of both domain and range. The final piece that we looked at in our literature review, Developing Algebraic Thinking Through Pattern Exploration, discussed how, in younger year levels, including primary school, exploration of patterns can be useful in guiding students towards an understanding of concepts, including domain and range, of both algebraic formulas and graphical representations of expressions. These findings can even be applied to high school level students in assisting in the development of their understanding and can lead to a deeper level of understanding of not just domain and range of functions, but also geometric pattern understanding and algebraic skills. Through further research, we have found out some more facts about student knowledge of domain and range. Students are found to often employ different mathematical approaches when solving for domain and range tasks. In activities involving both domain and range, students tend to focus on small, overly specific details rather than focusing on the bigger picture. This ties into the problem of students interpreting graphs piecewise, rather than as a whole function. Students have found to need more of what's called an objective view, where they see functions as a set of ordered pairs that can be acted on and considered as objects in and of themselves. Not only an operational view, where they're just a set of ordered pairs which have translations and changes happen to them.